Picture this. You're standing in a bland white hallway at NASA's Johnson Space Center in Houston. No windows, no phone, just a badge around your neck and a door in front of you labeled HERA Habitat. HERA stands for Human Exploration Research Analog, basically a fake space station on Earth. The door slides open with a hiss. Inside is a tight metal pod, about 650 square feet total, smaller than a lot of studio apartments, with bunks, workstations, a tiny galley, a ladder up to a small sleeping loft, and cameras in every corner. The lowest level is where you work and run experiments. The middle deck is where you eat, exercise, and argue about who's hogging the laptop. The loft is just enough space for 4 sleeping berths and a little privacy. Once you step through that door, it locks behind you. For the next several weeks, you cannot go outside. Your world shrinks to this box, 3 other people, and mission control on the other side of a delayed radio link. You keep a rigid schedule, follow scripted space procedures, and answer surveys about how well you're coping. This is where NASA practices the part of spaceflight most people never think about. Being trapped in a tin can with the same faces day after day without going quietly insane. But isolation is just one side of the problem. The other is what happens when the floor disappears. NASA will tell you there's no such thing as true zero gravity, just microgravity. But your body doesn't care. The minute you leave Earth, everything your muscles, bones, inner ear, and brain believe about down gets erased. Up to 60 to 80% of astronauts get space motion sickness in their first days in orbit. Nausea, vertigo, headaches, the works. So how do you train a human being to handle both? Months of isolation in a world where you never really stand up ever again? Today we're going inside NASA's training pipeline. From brutal analog missions on Earth, to one of the biggest swimming pools on the planet, to the psychological tools astronauts use to hold it together when they're weightless and can't go home. If you're into the real, unglamorous side of astronaut life, not just launches and hero shots, hit subscribe so this kind of deep dive keeps finding you. Let's step into the program. Who NASA actually picks. First, understand what kind of person even gets to this hallway. By the time you're walking around Johnson as a new astronaut candidate, you've already beaten odds that make the lottery look generous. Thousands apply. Maybe a dozen get picked in a class. Most are test pilots with thousands of flight hours, engineers who've run huge projects, doctors who've worked in high-stress environments, or scientists with serious field experience in remote places. The application process quietly screens for 2 big things: people who don't crack under pressure, and people who can play nicely with others when they're sleep-deprived and hungry. You don't start in a spacesuit, you start in a classroom. After selection, new astronaut candidates, ASCANs for short, spend up to 2 years just becoming baseline astronauts. It's like getting 5 different degrees at once: spacecraft systems, life support, orbital mechanics, space physiology, medicine, robotics, and even Russian language. You learn how the station's power flows, how the air is recycled, what words to shout if the smoke alarm goes off, and why a leaking ammonia line is one of the scariest sentences in space. You're drilled on procedures for American, European, Japanese, and Russian modules. You sit through briefings on orbital debris and radiation. On paper, that sounds like school. In practice, it's more like boot camp for your brain. You're memorizing acronyms by the hundred, learning how to read a stack of procedures in a crisis without freezing, sitting through safety briefs that calmly explain off-nominal events. NASA speak for everything is going wrong and you might die. Baked into all of this is something you never see on the launch broadcast: soft skills. Astronauts train in communication, conflict resolution, self-care, and team care. How to live in a tiny, confined space with people from different cultures without wanting to throttle each other. They practice something NASA calls expeditionary behavior: staying calm, clear, and constructive when the situation sucks. That sounds fluffy until you remember. On a 6-month mission, you can't quit the group chat. You can't mute the station. Learning to survive a bad landing. Before NASA lets you float, they make sure you can survive falling back to Earth in the worst possible way. So another chunk of training looks nothing like space and everything like a bad day in the wilderness. You do survival training for emergency landings, in water and on land. You're dropped into the ocean in a flight suit and told to get into a raft while waves slap you in the face. You practice getting out of a capsule mock-up upside down in a pool. You run through "we just landed in the wrong place" scenarios. Cold environments, hot ones, remote ones where the rescue helicopter might take a while. You also spend time in high-performance aircraft like the T-38 training jet. It's not just for fun. Flying fast and low in a tiny cockpit forces you to juggle checklists, radio calls, and split-second decisions. It trains the same part of your brain you'll use when a spacecraft starts throwing alarms you didn't plan on. In some programs, astronauts also ride centrifuges that slowly crank up the G-forces, the same kind of forces you feel on a roller coaster, multiplied, until they're vision tunnels. It's a preview of what launch and re-entry will feel like on their body, and a chance to learn how they personally react when the world goes gray at the edges. It's all about building a file in your brain that says, "I've been stressed and disoriented before. I can still think." Learning to move in microgravity. Once the basic knowledge and survival skills are in place, NASA starts messing with your sense of down. On Earth, you walk into the Neutral Buoyancy Laboratory, the NBL, a building the size of an aircraft hangar, housing one of the world's largest indoor pools. It's about 202 feet long, 102 feet wide, and 40 feet deep, holding 6.2 million gallons of water. At the bottom sits a full-scale mock-up of the International Space Station, the ISS. Before every major spacewalk, astronauts spend hundreds of hours here. You get sealed into a pressurized training suit that weighs hundreds of pounds on land. Divers lower you into the water and adjust weights until you're neutrally buoyant. You don't sink, you don't float. Turn your head and your whole body drifts. Push off a handrail too hard and you spin like a slow-motion fidget spinner. Each run can last 6 hours or more in the water, plus hours of prep and decompression. You emerge wrung out. Your shoulders ache from fighting the suit. Your fingertips are tender from gripping handrails. It's exhausting, but that's the point. Spacewalks on the real station are that hard, and you don't want your first brutal one to be in orbit. Down here, you practice every step of a spacewalk, what NASA calls an EVA, or extravehicular activity, over and over until it's muscle memory. How to move when your body wants to twist the wrong way. How to keep tools from drifting. How to cling to the station with your fingertips while your brain is still screaming that you're going to fall. A long-duration astronaut will log hundreds of hours in simulators and labs just to get ready for a first mission, and a huge chunk of that is this underwater dance. Simulators and the Vomit Comet simulation doesn't stop at the pool. NASA uses motion-based simulators and a virtual reality laboratory, VR for short, to teach astronauts how the station moves, how the robotic arm feels, and how their own bodies will react when gravity goes weird. You strap into a VR rig, grab virtual handrails, and rehearse entire spacewalks while your brain learns a new relationship with mass and inertia. It's not about pretending to be weightless. It's about teaching your hands to anticipate how a 200-kilogram piece of hardware will drift when you nudge it with a finger. The simulators also mess with your senses on purpose. You get thrown into spinning chairs and off-axis motion rigs that trigger the same inner ear confusion you'll feel in orbit. You practice doing simple tasks while your body is screaming at you to stop moving. The goal isn't to make you immune. That's not realistic. The goal is to make you functional even when you feel awful. On top of that, there are parabolic flights, the famous Vomit Comet. The aircraft flies steep parabolas, giving you around 20 to 30 seconds of microgravity at a time. It's just long enough to feel your stomach float. Watch a pen hang in midair and realize your inner ear is completely confused. Most people do not handle this gracefully. Around 60 to 80% of space travelers get some level of space motion sickness during their first days in microgravity. Training doesn't magically change that number, but it does teach you how to function through it, so how to medicate safely, and how to avoid making it worse with sudden head turns or bad timing. You learn which foods to avoid, how to move more slowly, and how to keep working when the horizon refuses to stay put. Building a space-proof body. Meanwhile, NASA is quietly preparing your body for a place where muscles and bones start to melt away. In weightlessness, your bones lose mineral density and your muscles weaken because they aren't fighting gravity. Without countermeasures, you can lose around 1% of bone mass per month in space. Leg and back muscles shrink. Blood and other fluids shift toward your head, giving astronauts that puffy face, skinny legs look in photos and messing with pressure in the eyes and inner ear. So before you ever fly, you live in a strict workout culture. Astronauts train like professional athletes. Resistance training, cardio, flexibility. Not to get shredded for social media, to build a buffer. The stronger your muscles and bones are on launch day, the more margin you have before space starts tearing them down. You also learn the space versions of those workouts. You get familiar with the ARED, the Advanced Resistive Exercise Device, a vacuum-based resistance machine that lets you lift weights without actual weights. You try out the cycle ergometer that bolts to the wall. You learn to run on a treadmill while strapped down with bungee-like harnesses that dig into your shoulders. It's awkward and slightly ridiculous, but on the station, it's your lifeline. Once you're in orbit, you're expected to grind through about 2 hours of exercise every single day just to keep your body from detraining. That routine starts on Earth, so when you finally float into the real hardware, it feels like another day at the office instead of a shock. Practicing isolation on Earth. But honestly, the hardest part isn't always physical. It's the isolation. That's where analog missions come in. Back in that Hera habitat in Houston, 4 people are sealed into a multi-level, 650-square-foot box for weeks at a time. The environment is closed. The hazards are isolation and confinement. You follow a strict schedule, run simulated space operations, and deal with events mission control throws at you. Equipment failures, communication delays, conflicting priorities. All while you can't step outside for air. Thousands of kilometers away, on the slopes of Mauna Loa in Hawaii, there's HICs, the Hawaii Space Exploration Analog and Simulation. It's a dome used for months-long Mars-style missions. Crews live under strict planetary rules, delayed communications, limited water, no casual walks in the sunshine. If you leave the habitat, it's in a mock spacesuit. You plan EVAs on the lava fields the way you'd plan trips across Martian terrain. These places are laboratories for human behavior. NASA and its partners watch how people cope over weeks and months when every annoyance gets amplified. Who withdraws when stressed? Who takes over in ways that create friction? Who cracks jokes that help the group stay sane? They measure sleep, mood, performance, and how the crew's tone changes as the days drag on. Out of those observations come practical tools astronauts are trained to use. Structured debriefs where the crew can safely complain, conflict resolution playbooks, personal coping plans that might include journaling, private time, or guided relaxation routines. You learn how to say, "I need 20 minutes alone," without turning it into a fight. Training the mind for the long haul. And then there's the mental health work no one sees. NASA's behavioral health teams train astronauts to do regular self-assessments, checking in on mood, sleep, and irritability, and to spot warning signs in crewmates. They plan out things as simple as care packages and as serious as private counseling sessions over encrypted video links. You rehearse what to do when you're angry and can't walk it off. How to talk to a teammate who clearly isn't okay. How to admit you're the one not okay without feeling like you failed. They also design your psychological support kit. Favorite music, photos, ebooks, maybe a small instrument or art supplies that can fly. You schedule weekly private video calls with family when mission timelines allow it. On station, you're encouraged to take time to just float at the window and look down at Earth. Not as a luxury, but as a countermeasure. That hit of home helps keep your head straight, because on a long-duration mission, isolation isn't just feeling lonely, it's a performance risk. If someone starts making small mistakes because their head isn't right, it can stack into something much worse. Mission training for the space station. Now take all of that, the classroom work, the zero-G training, the isolation experiments, the psych tools, and stack mission-specific training on top. For a long-duration mission to the ISS, astronauts typically need about 2 to 3 years of additional training beyond that initial candidate period. That includes travel all over the world: Russia, Europe, Japan, Canada. You're learning the specific systems you'll use, the experiments you'll run, the emergency procedures for each partner's module. There's an 18-month phase called increment-specific training, where you and your future crewmates run through integrated simulations together. You sit in full-scale ISS mock-ups while instructors throw every nightmare they can think of at you. Fires, ammonia leaks, depressurization, communication loss, medical emergencies. You practice until fire alarms feel boring. On top of that, you learn robotics. Driving the station's massive Canadarm2 to capture cargo vehicles or move large payloads. You rehearse medical scenarios where you might be the one performing CPR or stitching a wound with a doctor coaching you from Earth, so small misunderstandings don't blow up when you're stuck in orbit together. And just to give you a sense of how intensive even short missions are now, look at commercial flights. Private astronauts flying with companies like Axiom train for hundreds of hours over the course of a year just for a roughly 2-week stay on the ISS. For career astronauts staying months, it goes much deeper. Years of rehearsal before launch. All of this is happening while you're still on Earth. You wake up early, hit the gym, then plunge into 9 or 10-hour training days. One morning it's Russian language and robotics. That afternoon it's EVA procedures in the pool. Next day, emergency medical training and a team-building exercise that forces your crew to solve a puzzle while exhausted. Day after day, for years. By the time you're actually strapping into a spacecraft, NASA expects you to be almost boringly competent. There should be no surprises in how your suit feels, how your crewmates argue, or how it feels to float. The only surprise should be the view. Life on orbit. So what does all that look like when you finally get to space? You launch. Microgravity hits. Your inner ear freaks out, and you start feeling that familiar wave of space motion sickness you've rehearsed how to manage. Maybe you're one of the lucky minority who barely feel it. Maybe you're not, and those first 2 days are rough. But you know what to do. You've trained for it. You arrive at the station and push yourself off a handrail, drifting through a module that feels eerily familiar because you've lived in its mock-up back on Earth for years. Your sleep pod is the same size as the one in the simulator. The treadmill is the same one you've already cursed 1,000 times. The emergency procedures are exactly what you drilled until you could recite them half asleep. A typical day on orbit is a wall of scheduled blocks. Your experiment, maintenance, workout, meals, daily planning conference with mission control, more experiments, more maintenance, another workout, evening personal time. You have a full day off maybe once a week, and even then, you'll usually end up doing a bit of work. The weird part is how normal it feels. You float into a window and look down at the planet, blue, bright, rotating under you, and your brain should be exploding. But under that wave of awe is something calmer. This is what you prepared for. Your mental checklist is already ticking in the background. What's on the plan for tomorrow? What needs fixing? Who seemed off at today's debrief? The isolation hits later, weeks in, when you've watched the same people brush their teeth in a slow motion every morning and every night. When the novelty of floating through doorways wears off and the reality sets in that you are stuck here for another 4 or 5 months, that's when all the invisible training kicks in. The check-ins, the routines, the stupid running jokes that make the group laugh at the end of a long day. The mental habit of thinking, okay, this is just another sim, instead of, I'm trapped. The choice to grab the camera and film Earth for 5 minutes instead of doom-scrolling messages from home. The hardest part of the job. Here's the thing, rockets, capsules, spacesuits. Those are engineering problems, hard but solvable with math and metal. Turning a regular human being into someone who can live in isolation and microgravity for months without breaking? That's a different kind of engineering. It's hours in a pool pretending to walk in space. It's living in a fake Mars dome where stepping outside is forbidden unless you're suited up. It's learning how to tell your crewmate, "I'm not okay today," without shame. It's decorating a tiny sleeping bag taped to a wall so it feels like a bedroom instead of a locker. It's being willing to practice getting seasick on a parabolic flight just so you're less useless when your real spacecraft finally makes you weightless. By the time an astronaut is waving at the camera from orbit, the hardest part of their job has already happened. Down here, behind locked hatches and under fluorescent lights, where NASA quietly teaches them how to be alone together and how to float without falling apart. If you want more videos that peel back what life in space is really like, how astronauts eat, sleep, train, and cope, hit subscribe, drop a like, and stick around. Because the launches last minutes. The training for isolation in zero gravity lasts years.